Hello, and welcome to our next childhood psychopathology lecture. And today I'm going to be talking about intellectual developmental disorders. I want to make something clear about the set of lectures that are coming forth. These are not intended to be comprehensive, but to cover some of the significant issues in these areas. And so we'll be kind of hitting deep diving in a few areas that I think are particularly important. Today, in this first half, we're going to be talking about assessment of intelligent and intellectual development, in particular talking about the specific assessments and how to interpret the scores from those assessments. We'll then talk about genes and intelligence, and then spend quite a bit of time talking about environmental factors and intelligence. In the next lecture, we'll talk about some specific developmental disorders, briefly discuss treatment strategies, and then spend a little bit of time in learning disorders, which unfortunately the literature there is not particularly well established as far as I'm concerned. So, but let's first talk about assessment of intelligence and intellectual development. The assessment tools used in the intelligence field have been under development for about a century. The sort of earliest of those is known as the Stanford-Binet. It's been around since the 1920s. But this area is fraught with some difficulty. So there are numerous tools that can be used to assess intellectual development. The Wechsler Intelligence Scale for Children, or the WISC, which is now in its 5th edition, is generally thought to be the gold standard. The Wechsler Intelligence Scales for Children and Adult Intelligence Scales both require a licensed individual who is specifically trained in the use of that particular assessment device. Takes an hour to an hour and a half to complete and has a number of subscales. And as I said, is sort of generally thought to be the sort of gold standard for intelligence testing. Now, keep in mind there are a variety of different views of intelligence. There is thought to be a general intelligence factor, which is often thought of as G, crystallized intelligence, which is more facts learning, and fluid intelligence, which is problem solving, ability to think, and to reason, and then there's also emotional intelligence. And any of these assessment tools may capture some of those better or worse than others. The Stanford-Binet is another assessment device that is used for all ages, which makes it, to me, problematic for use in children, because what we expect children to be able to do is not what we would expect adults to be able to do. There are others: the Reynolds Intellectual Assessment Scales, Culture Fair Intelligence Tests, and the Differential Ability Scale. And the Differential Ability Scale does seem to be pretty good at doing exactly what it says, is trying to determine what differential abilities an individual child might have. So this is a quick introduction to these assessment tools. They take a long time of pretty significant amount of training to be able to be someone who can give those assessments. So now I want to talk about understanding the scores themselves. IQ scores have really pretty much always been based on relative performance. So while you do get a raw score, just like you would get a score on an exam, that is then converted into a relative performance scale. Classically, this is a ratio scale. The classic way we would do this is we would take the age at which a person operates and divide that by their actual age, and then multiply that by 100. So if somebody's intellectual ability is that of a 10-year-old and they're 10 years old, then they would have an IQ scale of 100. If someone can do beyond that, then their IQ would be above 100. So let's say their chronological age would be 25 or 20, but their intellectual ability is that of somebody who's 25. They would have an IQ of 125. And so this kind of ratio scale is still used, but differentially. We tend to use percentile scores still based on that mean of 100. So the most commonly utilized IQ scores are set at a mean of 100. So the mean intelligence across everyone that takes that test is 100. And then the standard deviation is set to 15 IQ points. So if you have an IQ of 115, you are one standard deviation above average. If you have an IQ of 130, you are two standard deviations above average. And based on the normal curve, we can then determine your percentile score. So we would use that to determine sort of where you are in terms of your percentile score. So the 50th percentile would be mean. Half of the population falls above, half the population falls below. So if you're in the 60th percentile, you performed as well or better than 60% of all test takers in your age range. So if you're in the 90th percentile, you performed at as well as or better than those than 90% of the population. And so that percentile score is part of this kind of ratio score. So it's one of the things to keep in mind, sort of where we are in terms of trying to estimate intelligence. And it is an estimation. We are using assessment devices to try to determine somebody's IQ. We can't take it out of their head and plop it on a scale and weigh it. So I do want to use some caution, or at least urge some caution in interpreting intelligence scales. IQ is quite variant during development, and any single IQ test is what we call a single point measurement. That is, it was their IQ on that day at that time. So stress, depression, and any other differential diagnosis might influence a single point measure. So if a child is depressed, under a great deal of stress, strain, they had a bad day, they're distracted, they have the flu, who knows? Any of those kinds of things might influence their score. And so we have to think of this as a point measure, and oftentimes think about if it's off from where we think it ought to be, we probably ought to measure it again. These measurements are also known for their cultural bias and can certainly be taken out of context. So there's a sort of classic, very poorly argued book called The Bell Curve, and in which essentially the authors try to argue that intelligence and race are inherently connected. And in fact, it has a lot more to do with these assessments and how people feel about themselves when they go to take their assessments. And so one of the things we have to do with these kind of tests is make sure people know that they are capable of scoring as high as anyone else. Otherwise, they oftentimes will score lower because of their personal beliefs about themselves. So that gets us to genes and intelligence. We estimate the heritability of intelligence at about 50%. It's about half of your intellectual ability is inherited, or your capacity for intelligence. And some important other questions about intelligence. First, I want to make clear we haven't identified the intelligence gene. We just know that if you look at twin studies and do a whole bunch of research, really the magic number comes out to about half of your intellectual ability is inherited. The stability of your intelligence, though, is also related to genetics, and this is an important argument. So about 24% of the changes in intelligence, so if you increase or decrease from age 11 to old age, that is related to genetics. But more importantly, the stability of your intelligence has a pretty significant genetic correlation of about 0.62. So going from 11 to senility, your genetics are going to play a key role in whether or not you maintain that intellectual ability as you age, from being a child to getting into older age in your 60s and 70s. So there is a significant genetic component to your intellectual capacity and whether or not you maintain that intellectual capacity as you get older. And so that's an important thing to keep in mind. So that gets us into environmental factors. If 50% is inherited, then the other 50% probably has something to do with environment. And this is a very complicated set of figures. And I'll show you a figure from the review article from which all of this information comes as we wrap up this section. So let's start with some pre-birth factors. So before you're even born, there are some risk factors. About 2 lectures from now, I'm going to be discussing autism, and a great deal of the risk for autism occurs before a child is even conceived. And so that's an important consideration. So older fathers are associated with lower intelligence, while older mothers are associated with higher intelligence. Not entirely clear why. We'll talk about Fragile X syndrome, and that seems to be associated somewhat with older fathers. And this is also a risk for autism. Prenatal nutrition, very important. Iron, folate, B12, and iodine deficiencies. If any of these are deficient, they can be associated with lower IQ. That iodine deficiency, one of the things it can do is trigger a thyroid problem, and that thyroid problem seems to be what triggers intellectual difficulties. I want to make it very clear the CD recommends that pregnant mothers consume no alcohol whatsoever. So that is the recommendation. The data show normal drinking in mothers with a slower alcohol metabolism is particularly at risk. So there are certain genotypes in which people either lack or have very little alcohol dehydrogenase. And so as a result, their alcohol metabolism is very different. Heavy drinking in those who have the appropriate levels of alcohol dehydrogenase are also associated with fetal alcohol syndrome, and that includes significant intellectual difficulties, facial abnormalities, and some other difficulties. Another issue is exposure to other toxins prenatally, particularly cigarette smoke, which is associated with low birth weight, which is associated with lower intelligence, air pollution, pesticides, lead, and other heavy metals are all associated with lower IQ. And so exposure to pesticides is going to be particularly problematic for agriculture workers, people who are around those pesticides all the time. So we want to be very careful about that. Lead and other heavy metals, in particular mercury, is one of the reasons why pregnant mothers are told to avoid certain fish, in particular tuna, swordfish, sort of top of the chain fish are oftentimes problematic for those that heavy metal exposure. Obviously, we have significant issues in the United States with our infrastructure. The house I'm living in at the moment has lead service lines, and the Denver Water Department has provided filter pitchers on a regular basis to make sure that we are filtering out any lead in the water that's drunk here. So you want to be very cautious of that. And certainly think about using a water filter no matter where you live, just to be on the safe side. So those are all prenatal. That gets us to at birth factors. Preterm delivery is a pretty significant risk for intellectual difficulties, and the more preterm, the higher the risk. Any infant that has very low birth weight, and again, this is associated with preterm delivery, so these are two that go hand in hand. Low birth weight is also associated with cigarette smoking. In a congressional deposition back when big tobacco was being investigated a great deal, one of the tobacco executives actually had the gall to say that some women preferred smaller babies. But this is a significant risk factor, is exposure to cigarette smoke and other air pollution. Finally, low sort of normal range birth weight in males is also associated with reduced intellectual capacity. So while it might be considered normal birth weight, if it's a low birth weight in a male, then it's considered a risk for lower intelligence. So as we move into the early development phase, now we start getting into a variety of issues that have some societal implications. The first of these is breastfeeding. This has been associated with increased intelligence, but there are a lot of covariates that go along with breastfeeding. And so I'm not very secure in making that argument. The association is there, but breastfeeding also has a number of other covariates, including race, socioeconomic status, occupational status, etc. So there's a lot to go along with that. For children who do not have stable homes, moving them from institutional care, so say an orphanage, to foster care as early as possible, or moving them into adoption as early as possible, is associated with significant increases in intellectual capacity. Child-parent interactions, this gets sort of at the previous point. Reading to children really facilitates verbal development and other intellectual development, particularly parent-child reading together, sort of interactive. There's a lot of data about doing things together and how that fosters intellectual development, not reading at the child, but reading with the child, and that's really important. Children who attend preschool tend to fare better than those who do not. So as we start thinking about public policy implications of some of this data, that one is particularly important. And in the state of Colorado, we have moved to full-day kindergarten and moving to increased preschool based on this kind of data. So that gets us to factors relevant across early development. This is sort of across those early years. One of the most significant risk factors for brain development is poverty and parental socioeconomic status. Lots of studies showing reduced interhemispheric connectivity, lower gray matter volume, and these are directly associated with lower IQ. Martha Farah and some of her colleagues have done a great deal of work in this area, which I urge you to take a look at. Very important from both a public policy perspective and particularly when we start thinking about people who are sort of locked down at home during things like the COVID quarantine times. Corporal punishment and witnessing domestic violence are both associated with lower intelligence regardless of other variables, including SES. So while domestic violence and corporal punishment oftentimes co-vary with lower SES, in this case, these are independent of that. And so don't get me started on people who post memes about how they got spanked as a child and how kids would be better off if they were spanked, because they wouldn't be. And that's very clear based on the data. Dietary interventions, particularly increased omega-3 fish oils, show positive results. This is one of those supplements that I just recommend to people because it can't hurt. And just increasing the amount of fish in diet, Mediterranean diet, lower fat, lower carbohydrates, more protein, more vegetables, fruits, vegetables, and nuts. All these are associated with pretty positive results. Finally, fewer hours watching TV may be associated with IQ. This is a chicken and egg problem, as we like to say in the business, or a correlational problem. We don't know the directionality of this particular association. It's entirely possible that kids who don't have learning disorders such as dyslexia are more likely to read, and as a result, they're reading more and their IQ goes up. So this is one of those you're going to have to untangle a little bit more of. Just simply keeping kids from the TV is not probably the answer. So as we get into later life development, some really interesting data on music lessons. Highly recommend music lessons for kids, particularly those that might be struggling in math. There are clear associations between music lessons and intellectual development. The amount a child reads, again, we have to think about covariates such as dyslexia, which I'll talk about in the next lecture. But the more they read, the better off they will be. Cardiovascular health, another important component. One of the reasons why we need to think about keeping physical fitness education in the schools. Kids don't have to be in sports, but keeping them healthy, walking, out jogging, doing whatever they might enjoy, running around being kids, probably will definitely help out. There are reductions from in intelligence from fight injuries. Probably some covariates that go along with that as well: stress, bullying, that sort of thing. Tobacco use and youth marijuana use are both associated with reductions in intelligence later in life. Adult use is not. There's something about the developing brain that puts it at particular risk from marijuana use. Finally, repeated head trauma can be associated with poor long-term outcomes. So this is where we start thinking about sports injuries and intellectual development. I was not having any luck finding any good data on this particular problem, but we do know there are other poor long-term outcomes, including mental health. And so we all ought to be thinking very carefully about youth sports participation. So all of this came from this, I'm not even going to try to slaughter these two folks' names, Takuchi and Kawashima. I'm going to try that article. Really terrific summary of all of these issues. We start at fertilization, high paternal age, reduces full intelligence, which is what the F stands for. High maternal age increases full intelligence. All of these are associated with reductions in full intelligence, including being a twin. I'm not entirely sure why that is, but there does seem to be some sort of prenatal issues there. At birth, preterm, low birth weight, early development after birth, breastfeeding, interactive reading, preschool, parent-child interaction in particular increases verbal intelligence. Developmental phases after birth, poverty, maltreatment, sleep disorders, parasites, which is particularly a problem in third worlds, and TV watching, all associated with reductions, while nutrition and healthy foods are generally associated with increases. Then we get to music lessons, reading, cardiovascular health, and education, all improvements, and then fighting injuries and smoking and cannabis, reductions in intelligence. So lots of things going on with the environment associated with intellectual development. In the next lecture, I will pick up on some specific intellectual disabilities and talk about learning disorders.